All right, recurrence relation. Gang, here at Nick Does Maths, we have a second order linear recurrence relation, which we're going to solve. We're going to look for a solution that looks something like this, a lambda to the n. We plug that in, and much like with a second order differential equation, we end up with a nice sort of characteristic equation here. Lambda squared minus 4 lambda plus 5 is 0. Looks like it factorizes, in fact doesn't factorize. So we get lambda is 2 plus or minus I. Now, in order to turn this, because we want a real, right? We want a real sequence un, right? We want a real sequence. So that is a problem for us. But if we choose our a's and b's carefully, now remember that is basically modulus argument form is root 5 e to the plus or minus theta, with tan theta as a half, so that gives us that one right there. If we choose our a's and b's carefully, I can turn this into un, so I can go from un equals, because my lambdas are complex conjugates, right? So a times 2 plus I to the n plus b to minus I to the n. By thinking of these in modulus argument forms and picking a and b carefully, I can turn this into, I'm going to get a root 5 to the n, which is 5 to the n over 2. And this basically becomes a cos n theta, well, I don't know, call it a star, plus b star sine of n theta. By choosing a and b being complex conjugates and things like that, I can get to this result. Now let's plug in our starting condition. U0 is 0. Times a star, and that's it. So a star is 0. And then 1 is 5 to the 1/2 times b star sine theta. Okay. So we end up with un is b star, which is 5 to the 1/2 over sine theta, times 5 to the n over 2 sine n theta. Okay, I'm just going to write that over here. That looks horrible, but it is what it is. Sine theta times 5 to the n over 2 sine n theta. Okay. Do what you must. Okay. Now we want to multiply it by some of these things. So let's go case 1. A is 0.1, also known as 1/10. So Vn becomes, this doesn't change. I'm just going to keep this as my b star. I don't really want to keep writing that. That just makes me unhappy. If it comes up, we'll see in a second. So we get 5 to the n over 2. 5 to the n over 2. So, but we also get that. So we get 1 over 10 to the power of n over 2 times 5 to the power of n over 2 times sine n theta. Well, b star then is 5 over 10, which is a half to the power of n over 2 sine of n theta. Now, as n goes to infinity, this thing will oscillate, but importantly, that goes to 0 as n goes to infinity. So Vn will just go to 0. Okay. What if A is 1/5? Well, you might see what's about to happen here. Vn is then that b star, that horrible number there, times, and we get a 5 to the n over 2. I get a 1 over 5 to the n over 2. which is just b star sine of n theta. So what's this going to do? Well, this is going to oscillate. All right, this is going to oscillate between set values, which will be sine of theta, sine of 2 theta, sine of 3 theta, sine of 4 theta, and so on and so forth until it loops all the way back round. But you're going to get these, this oscillatory nature, and at most, all right, it's going to be between 1 and -1 at absolute most. We could probably dig into that a little bit more by looking at what sine theta is, but the real thing is to see that these terms cancel out, and we end up with this oscillation. Now, if A is 1, then Vn is just b star 5 to the n over 2 sine of n theta. This, well, that will oscillate, but that is going to get huge. That is going to get really, really big. So essentially, Vn is going to go to infinity. And there we have it. Nice and straightforward. The solving, we had to deal with some complex numbers, not the most fun anyone's going to ever have, but it's okay. A standard approach we need to know, and then having a little think about what happens as we start blowing this thing up or scaling it back down. Don't forget to like, subscribe, hit the bell for notifications to make sure you don't miss the next one of Nick Gets Confused Doing Maths. I will see you next time.